Alright guys, so as we open up 1.5, we're going to start looking into some more unique linear and squaring functions. And at the conclusion, we're going to spend a lot of time on what we know as the step function. But let's first kind of just talk. Let's just talk here about what a linear function actually is. So what's the linear function? Well, you guessed it. A linear function is a function that gives us a line. Plain and simple, that's all it is. That's what a linear function represents, some kind of input-output that is going to produce a line. So what does the equation of a linear function look like? Once again, you guessed it. All right, it looks like the typical slope-intercept form, or y equals mx plus b. That is what identifies us as a linear function. And then as you dive deeper on into its characteristics, you start asking yourself the question, well, what are the domains of all linear functions? Well, the domain of all linear functions are going to end up being the set of all real numbers. Now this is of course understanding that there is no discontinuity anywhere, and I'm not talking about discontinuous types of functions. This is a continuous linear function. Of course, it's going to have a domain of all real numbers. And so then what's the range of a linear function going to be? Well, the cool thing about linear functions is that they hold the same properties for the domain, and their ranges will go off into negative and positive infinity, both vertically and horizontally as well. And so what's the point of kind of talking about this? It should be review for us, right? Well, what if we start kind of just getting characteristics of functions and we're not given necessarily point values, or maybe we're not even giving the equation itself. We're given just some random characteristics about it. How can we find out some more information? Well, let's take a look. About a linear function in which when you input the value of 1, you get a y value of 3. When you input the value of 4, you get a y value of 0. So the question I have on here is, what do we know? What does f of 1 equaling 3 and f of 4 equaling 0 actually tell us? Well, let's think for a sec. What is all the inputs? These are just x coordinates. What are all the outputs? Just y coordinates in there. So technically what we know is that we have a point, I'm going to call it P, at 1, 3, and we have another point at Q at 4, 0. Well, now you've identified that we have two specific points on this line. And if you remember correctly, as long as you have 2 points, you can easily find the slope, and you can easily find what our values will comprise of our linear equation. Remember how I wanted you to start thinking about slope? I wanted you to start thinking about slope as change in y over the change in x. Well, what does that look like in terms of what they gave us? Well, they gave us the change in y, which was really f of 4 minus f of 1. And what was the change in x? Well, the change in x was 4 minus 1. But we happen to know that the change in x of f of 4 had a value of 0, and that f of 1 had a value of 3. And so we end up coming to find out that the value of the slope is at -1. But again, I wanted to show this so we can start visualizing slope in changes in y versus changes in x. Now we have these two values. We can easily write the linear function. And so we have a point and we have the line. Y minus one of the y1s, I'm going to use p, equals -1 times x minus 1. We get y minus 3 equals -x plus 1. I'm going to add the 3 on over, and we get -x. 1 plus 3 ends up giving us a positive 4. So because we want it in function notation, we're going to make sure we switch it on out and turn it into function notation. All right. So again, we're not reinventing the wheel here, but I do want to show and to understand some of these institutions of what does the change in y actually look like? What does the change in x actually look like? And what can it show us about average rates of change? All right, guys, that's going to do it for this very short video, and we're on to the next one.